Today we're going to learn about waves. Waves are simply a disturbance that can travel through space or matter. Wave motions transfer energy from one place to another. There are two types of waves, mechanical waves and electromagnetic waves. A mechanical wave is a wave that travels through some sort of matter which is called a medium. In this example, the medium is the rope. Electromagnetic waves, on the other hand, such as radio waves or waves of light, travel at the speed of light and consist of a combined electro and magnetic effect. They can even travel through space. Let's start with mechanical waves caused by turning on this faucet. The frequency of a wave is the number of waves per second that the wave cycles. Frequency is measured in hertz or cycles per second. It's represented by the formula speed divided by wavelength. We're going to use the example of water. In our example, if we increase the frequency, there are more waves per second. If we decrease the frequency, there are fewer waves per second. Wavelength is measured as the distance between two identical points on back-to-back waves. In our example, we can use the tape measure to measure the distance from the top of one wave to the top of the next. In this case, it's roughly 1.9 centimeters. Amplitude is the distance that a wave dips down or rises higher than its calm or flat surface, which is the starting point to measure a wave's amplitude. In our example, when we increase the amplitude, the waves get larger, and when we decrease the amplitude, the waves get smaller. Amplitude measures the energy of a wave. The greater the amplitude, the more energy the wave has. These waves have been transverse waves. In other words, they transfer energy in a motion that is perpendicular to the direction the wave is traveling. The waves are moving from left to right, but the disturbance is going perpendicular or up and down. The second type of mechanical waves are longitudinal waves. Longitudinal waves travel in the same direction as the disturbance that caused it. In this example, we're going to look at sound. Sound is made up of vibrations, or sound waves that we can hear. These sound waves are formed by objects vibrating or shaking back and forth. Sound waves travel through air, water, and solids. Unlike electromagnetic waves that can travel through space, sound waves are mechanical waves, which means they require a medium. I'm going to use my voice for a demonstration for the following examples. A sound's amplitude is a way of measuring volume. Higher the amplitude, the higher the volume. Low amplitude sound waves have low volume. High-frequency sound waves have shorter wavelengths and higher pitches. Low-frequency sound waves have longer wavelengths and lower pitches. We're going to look at electromagnetic waves. Remember, these are waves that travel at the speed of light and consist of a combined electric and magnetic effect. Unlike sound, a mechanical wave, electromagnetic waves can even travel through space. Electromagnetic waves include radio waves, which are used to broadcast radio and television, microwaves, which are used in cooking, radar, and telephone signals, infrared rays, which transmit heat from the sun, fires, and radiators, visible light, which makes things able to be seen, ultraviolet light, which is absorbed by the skin and is used in fluorescent light bulbs, X-rays, which are used to view inside of bodies, and gamma rays, which is used in chemotherapy for killing cancer cells. We're going to examine visible light more closely. If you increase the amplitude of the light, you increase its brightness. If you decrease the amplitude of the light, you decrease its brightness. Frequency affects the color of the light. Low-frequency waves have longer wavelengths and less energy than high-frequency waves, which have shorter wavelengths and more energy. Red waves have the lowest frequency, the longest wavelengths, and the least energy. Violet waves have the highest frequency, the shortest wavelength, and the most energy. Remember that white light is a combination of the entire visible light spectrum and can be absorbed, transmitted, reflected, and refracted. Absorption of light occurs when an object does not reflect or transmit light. The energy of the light is instead absorbed by the object itself. Light is transmitted when it passes through an object. It is reflected when it bounces off an object, like is happening in our mirror. It is refracted when it is bent, as happens in our prism. In this